Okay, in this video we're going to talk about number 2 from the 2015 Calc BC exam, and it's a pretty straightforward kind of parametric slash vector function problem. So let's see, we're told that v of t is cosine of t squared comma e to the 0.5t. We also know that at t equals 1, the particle is at 3, 5. So the first thing I do with this problem is I define dx. So I literally type d and then x of t. That's how I store derivatives, dx and then dy. So dx of t is cosine of t squared on my calculator, and dy of t is e to the 0.5t on my calculator. And that lets me just use them efficiently, and I don't have to worry about typing it in again. And I also know that at t equals 1, the point's at 3, 5, or the particle, or yeah, it's a particle. It's at 3, 5, and in this question I have to find the particle's position, or no, just the x-coordinate at t equals 2. So I'm going to say that x prime of t is cosine of t squared, and so x of 2 should be x of 1 plus the integral from 1 to 2 of x prime of t dt, which means that x of 2 is 2.557 is what my calculator told me. So that's the particle's position at t equals, no, that's its x-coordinate at t equals 2. I really wanted this question to be about position. Okay, so the next question is asking where between t equals 0 and 1 is the slope of the curve equal to 2. Well, I know dy dx is dy dt over dx dt, and I know that dx dt is cosine of t squared. I know dy dt is e to the 0.5t. Also, I have those stored on my calculator as dx of t and dy of t, so that I can just use them. And this question is asking me to solve dy dx equals 2. My calculator told me that was at t is approximately 0.840. I actually use solve on this, which I don't really recommend because they usually pick problems where solve doesn't work very well. But it did work in this case. And it gave me, I limited it to be between 0 and 1. And it gave me that. You'll get like a bajillion solutions if you don't do that. The safer thing to do is to actually graph dy of x divided by dx of x. You have to use x or it won't graph. And also graph 2, and use the built-in intersection. Make sure you change your window before you do that, because there are a lot of solutions to this outside of the interval, and this is a safer method. I always recommend my students do that rather than use solve, but in this particular case, solve actually worked for you. So part C, I need to find the time at which the speed of the particle is 3, so I'm going to have to write down how to find speed. Well, speed is the magnitude of velocity. So it's going to be square root of x prime squared plus y prime squared. And in this question I need to basically solve that equal to 3, which again is calculator. This is all like writing tiny little equations and using your calculator to just kind of brute force it for you. My calculator said that that was at 2.196, and again I used solve on that. But a safer thing would be to graph and find the intersection with 3. And finally, part D, total distance traveled. So total distance traveled is just the integral of the speed. So it's the integral from 0 to 1 of x prime squared, the square root of x prime squared plus y prime squared. And my calculator says that's 1.595. That's the entire question, and I hope you found this helpful. Good luck.